Hello viewers, you are welcome back to Tindanius Maths and Science Tutorials. Today we are going to talk about complex numbers that are complex. So now, most of the times we've been talking or we've been dealing with the real number system, right? We have the real number. But this time around, we are going to dive into a number system. It's a number system, but this time around, it is not real number system, but a complex number system. And in this case, mostly denote complex number by the letter Z, or how you or whatever way you call it. Some people call it Z, I call it Z. They also mean what they say. So my complex number here is represented by the letter Z. This way, good. Now, complex number is always in the form a plus b I, or Z is equal to a plus I b. Algebra is still correct. So where C is therefore my complex number, and then A here represents the real part of the complex number. So where my A denotes what? The real portion, the real portion of the complex number. Then my B is the imaginary part or portion of the number, and simply my I here denotes imaginary units. So imaginary units. So when you have numbers in this form, it's simply what a complex number. So, in a nutshell, let's say a complex number is just an extension of what? Of the real number, including what? Imaginary parts. Real numbers do not have what? Imaginary parts. Alright? So, for example, if I have example of complex numbers, we have Z equal to A and A equal to This is a complex number. So that is the whole issue of a complex number. Okay, so we are going to learn on how we can add complex numbers. We are going to learn on how we can subtract complex numbers, multiply complex numbers, and divide complex numbers. So, let's say before you can do this, you have to understand the imaginary units or the imaginary part of the complex number. So, which is the I. So let's understand this. So my I squared will give me -1. Viewers, I don't expect you to do root learning, chew and pull. You have to understand what the concept. You have to understand how you can deduce it. So when I take the square root of both sides, I'll have this. So taking square root of both sides, I'll have, let's have this way. Then I take square root of both sides. So 2 takes off the radical sign. So I'll get what? I equals what? Square root of what? Of -1. Viewers, remember when we were in SHS, you could solve mathematics at a point in time when you try to find the negative square root of numbers. Immediately you punch that into your calculators, it becomes what? An error. But in advanced mathematics, you realize that there is a way forward. So that is what? The complex number. It's a complex number. That's why the calculator could not what? Simplify it what? Further. So you have to understand these things. Alright? So I squared gives what? Negative 1. I equals what? Square root of what? Negative what? 1. So what about if I have I cubed? Alright. So we know that I cubed can be, if I write I cubed as I was squared multiplying what? I. This I is raised to the power 1. So when you add the corresponding components, it yields what? 3. So I can now have I cubed equals I squared. Do I know I squared? Of course, yes. So what I'll do is I'll substitute what? My I squared, which is what? Negative 1. So I have my negative 1 times what? Times my I. So I cubed will give you what? Negative I. Viewers, do you want to memorize this? No, you can deduce this. So the standard or the basic thing you should know is I squared, and the I squared can do the work for you. You don't have to what? Memorize stuff over here. Good. So using the same analogy, what of I raised to the power 4? So I raised to the power 4, whatever way you can do. So you can just see here was I cubed. So I was able to express I cubed as what? I squared times what? Times I. So here is what? Either I what? Q times what? Times your I. Or whatever way you do, just make sure that your mathematics or your algebra is proper here. So I raised to the power 4. One can also express it as I raised to the power 2 times I raised to the power 2. You will still get what? The same answer. So let me work with this. So I raised to the power 4 equals I squared. Do I know I squared? Viewers. I squared is giving me what? Negative what? 1. So I have my negative 1, then times I squared. So I have what? Negative 1. So I raised to the power 4 is equal to negative and negative. When they commute, you get what? Positive. 1 by 1 gives what? So I have positive what? 1. So this is negative 1 by negative 1. It gives what? Positive 1. So in summary, so we have this. We know that from here, I is equal to square root of negative 1. I squared equals what? Negative what? 1. Then I raised to the power 3 gives what? Negative I. Then I raised to the power 4 gives what? 1. Viewers, you can continue with this till you get to the number of your choice, then you stop. So what happens if you have bigger exponents or powers? Are you supposed to do this? For instance, let's say if you have I raised to the power 4,302. What? Will you try to split it this way? That will be very what? Difficult. You get it that way. So we have another way to what? To reduce this in order to what? To continue doing your work. So how do we do something like this? So let's say, let me increase the power to, let's say if you have I exponent, let's say I have exponent 25. Do you get it that way? So what is the fastest approach to this? So what you are supposed to do is, first of all, you will divide the power of the exponent by what? By 4. By 4. So if you have this, is just what the calculator what work. So if you divide this by 4, so we have 25 over 4. I have by 25 over 4. By the help of the calculator, you divide this over 4, you are supposed to get 6.25. Afterwards, we are interested in the whole number part. So you pick the whole number part, which is what? Which is by 6. Then I will multiply the whole number part by 4. So I'll multiply 6 by what? By 4. I'll get 6 for 24. Whatever you get, you subtract this from the original power given in question. So what do I have here? I have my 25, then minus what? Minus my 24. So I'll get what? I'll get 1. So as a result of that, I can clearly and boldly say that I raised by 25 is the same as I have my I over here, then exponent what? This number represents what? The exponent what? 1, which is the same as what? My I. So I raised about 25 is the same as what? The same as what? The I. 1. Or, so alternatively, before that, let's do a short recap. When we have higher exponents, what do we have to do first? Divide the exponents by 4. You get what? A whole number part and a decimal part, right? You pick the whole number parts, you multiply it by 4. It yields what? Another result. So what you have to do is, you subtract the 24 from the original power to get the remainder, which is what? The 1. Alternatively, this time around, the decimal part represents the remainder. You get that? So you just multiply the decimal part by 4 and you get the answer straight away. That's the remainder part. You took the remainder part, so you don't have to search or look for any remainder. But here you took the whole number parts, multiply by 4, you subtract from this to get the remainder. You get that any of them would work for you. So let's try that. Alternatively, we have I exponent 25. So if I divide 25 by 4, you said you are getting what? 6 points. Again, so we have 6.5. This time around, I'll pick what? The decimal part. So which is what? So I have 0.25 times my 4. So 0.25 by 4 straight away gives what? 1. So I raised power 25 is equal to the I raised to power 1, which is this. As simple as that. So what are the numbers? Let's pick huge numbers, okay? So let's say we have I raised to power 9,305. This is very huge. Again, you cannot go through this. You get what? Exhausted. So how do you go about it? So the normal norm, the normal convention. What are you supposed to do first? Divide this by what? By 4. So I have 9035 over 4. I'm getting 2. So I have 2,258.75. Then I will not pick the whole number part. So I'll get 2,258 by 4. So I have 2,258 by 4. And I'm getting 9032. What do you have to do next? You subtract this from what? From that. So if you subtract this, 9035 minus 9032. Straight away you get what? You get 2. So therefore, I can say I raised the power 9035 is the same as. Sorry viewers, this 3. Alright. So if I have I raised the power 9035, I'll get what? I raised the power what? 3. You can still use what? The decimal what? Portion. So if I use the decimal portion, I have 0.75 times my 4. So if I have 0.75 by 4, I'll get what? 3 straight away. Viewers, this is how simple complex numbers can be. Do you get it that way? So having understood this, we are going to learn how to add complex numbers, subtract complex numbers, divide complex numbers, and multiply what? Complex numbers. Okay, so let's see what happens from here. So let's start with addition of complex numbers. But again, before that, let's consider this also. So let's say if I have, let me consider the perfect squares. So if I have square root of 25, I'll get what? 5. Square root of 36, I'll get 6. So square root of 100, I'll get what? 10. Square root of 4, I'll get what? 2. What about this? Square root of negative 25 gives what? Square root of negative 36 gives what? Square root of negative 100 gives what? Then square root of negative 4 also gives what? That is the business for today. So what we can do over here is this. So if I have square root of negative 25, what I'll do is I'll look for two numbers. When multiplied, will yield what? 25. So in my multiplication process, I will discard the negative one from what I'm doing. I'll bring the negative one later in the course of calculation. So this is the same as. So what are the two numbers? 5 by 5 gives 25. So I have 5 times what? Times 5. You realize negative has been what? Has been what? Discarded. Then times the negative left, which is the negative one. I'll also put it what? Under what? The radical. Sign this way. So because this and this are, are the same. So I'll just pick one. I'll just pick the radical because they are the same. Just pick the radical, that's all. Then I have what? Times what? My negative 1 this way. But we know that I squared is equal to what? My negative 1. Then if I take the square root of both sides, I'll have I is equal to what? Square root of what? Of negative 1. So I can therefore conclude by saying 5 by the square root of negative 1 simply gives what? I. So I'll get what? I'll get 5 what? I. So therefore, square root of negative 25 gives what? 5i straight away. Let me see how simple this can be. So you can use the same analogy over here. So if square root of positive 25 is giving me 5, then square root of negative 25 gives what? 5, then you add what? I. So this becomes what? 6 what? I. This becomes what? 10 what? I. And this becomes what? 2 what? I. You can use this. You get the answers. So this is just for what? For perfect what? Squares. So what about let's say you have let's say square root of negative 20. When you put this into the calculator, it appears as what? As a syntax error, but there is a way out. So here, first of all, I'll discard the 20. I'll multiply two numbers to give me 20 as if I didn't see any negative sign over there. So I'll get, so let's say I have square root of 4 times square root of what? 5. This gives me 20. Then the negative left, that's the negative 1, will come here. Square root of 4 gives what? 2 times square root of what? 5. Then I have what? My negative 1. But you know that I is equal to what? Square root of negative 1. So I'll just put this over what? Over here. So I'll get negative 20 is equal to 25. They have square root of 5. As simple as that. So we can now start with the addition of complex numbers. So we said complex numbers Z can be expressed in this form: a plus I plus b, this way. So let me call this Z1, and I have Z2, which is equal to, let's I have my A, then plus IB. So addition of complex numbers, I'll add this to this. So let Z represent the resultant of the 2. So I'll get what? Z1 plus my Z2. Why plus? That's because I'm doing what? Addition. So what is my Z1? My Z1 is this. I have A plus IB. Then plus Z2, which is this. A plus IB. Then you group like this. The real are corresponding real numbers and corresponding imaginary parts. So the real numbers are the real number parts. That's A and B. So A plus A over here. Then you add the imaginary part, which is IB plus IB. Then you can simplify. So I have 2A plus 2IB, giving you what? This. So let's take examples under the addition of complex numbers. Okay, let's add this. So add or evaluate the following. We have if z1 equals 5 plus 3 I, then z2 equals 2 plus 7I. So let's say add z1 and z2 this way. So let's add them. So I have z1 plus z2 equals 5 plus 3I plus z2, which is 2 plus 7I. So I'll group like this. The real parts are 5 and 2. So I have 5 here plus 2 plus 3I plus 7I. Then I have this plus this is what? 7. Then plus 3 plus 7 is 10 what? I. So there's it. So when you add two complex numbers, you will get a complex number. So I have a complex number here, added to a complex number here. The result is what? Is a complex number. So let's say we have here to be negative over here. And we are supposed to add them. The same thing goes for them. So we have z1 plus z2 equals 5 plus 3I added to z2, which is 2 minus 7I. So I'll group like this. Real parts, so we have 5 plus 2. Then add the imaginary part plus 3I minus 7I. 5 plus 2 gives 7. Then minus 4I. So that is what the result of z1 plus z2. Viewers, this is the end of addition of complex numbers. So let's work out for subtraction of complex numbers. So for the subtraction, it's just the same format, the same concept. So if you have z1 equals, let's say zx equals negative 6 minus your 3I, then zy equals 2 plus 4I plus 6. So find or evaluate zx minus y. So zx minus zy becomes, what is zx? Zx is negative 6 minus 3I. Subtraction. So minus, what is my zy? My zy is the whole of this expression. I have 2 plus 4i plus what? Plus 6. So I'll have negative 6 minus 3i, then minus into bracket. This is a real number, there's a real number part and there's a real number part. So you can add them because they are adding. 2 plus 6 gives what? 8. Then I have plus what? 4i, which is equal to I have negative 6 minus 3i. Then this is an expression, so what will expand the bracket. So negative 8, then negative by positive gives negative. Then I have 4i. Remember to group like terms, real number part and what? Imaginary part. So where are the real number parts? We have negative 6, negative 8. So we have negative 6 minus 8. Then we have negative 3i minus 4i. Then negative 6 minus 8 gives what? Negative 14 minus negative 3i minus 4i gives what? Negative 7i. Viewers, this is how the subtraction goes. That subtraction of complex numbers. So the last example we have under subtraction of complex numbers. To find or evaluate z1 minus z2, where z1 is equal to negative 10i plus 7, then z2 is equal to 1 plus I. So viewers, the same concept. So we have z1 minus z2 equals, what is z1? So viewers, by rearrangement, this is the same as, you know, the real number comes first, right? So we have 7. Then the imaginary number goes out. 2 minus what? Minus 10 I. So it's the same. So what is z1? Z1, we have this negative 10i plus 7. Then minus z2, we have the expression 1 plus I. So I'll have negative 10i plus 7, then minus 1 minus I. So we have negative 10i and negative I. So I'll get negative 11 what I. Then plus 7 minus 1 is what? 6. So by rearrangement, why rearrangement? We know that the complex number C is equal to A plus 1. Where is my imaginary? Sorry, my real number part. This is the real part. So here the real part is the 6 and the imaginary is what? The negative 11. So my rearrangement, so I can say z1 minus z2 is equal to the real part. We have 6 then minus 11. Viewers, this is the end of the lesson. Always try to subscribe, like, comment, and share as well. So far as Timdaniel Science and Maths YouTube channel is concerned, in fact, we are going to explore, we are going to learn a lot.